Hey everybody, my name is Jason, also known as Pirate JC, and welcome to another Babylon video. Today we're continuing to explore my childhood and the thing that spawned the pirate obsession, and that is pirate Legos. Yes, this awesome little cute scene where we've got this Lego sea of little studs, thin instant studs, and of course a Lego pirate ship floating on top of them. In our last video, we went over how to take a single Lego stud and create a bunch of thin instances of it, telling the GPU to render them in different locations with a material applied to all of them that takes into its world of position into account. Mind-boggling, right? But super fun. If you haven't already checked out that video, I encourage you to start there. Today, though, we're continuing our work by adding on the black pearl into this scene and then adding some physics to give it that nice little rocking motion. And we are going to start directly where we left off in the last video, and that is right here in this scene. You can find a link to this playground in the description down below. This is right where we left off before. In fact, we're actually going to undo what we did before and essentially sort of start over. Not entirely, but we're going to comment our work out from last time so that we can have a nice clean scene. Now this scene just has a skybox, an environment texture, the camera setup, and then of course physics is already enabled. Okay, we're using the Canon.js plugin for this. So to show off how we're going to do this, how we're going to create the rocking motion for the black pearl, essentially it's actually quite simple. We're going to take a sphere. That sphere is going to sit on top of a ground plane. And there's going to be a pendulum, a heavy counterweight underneath that ground plane that's connected to the sphere. So as that counterweight moves, if we nudge that counterweight, it will rock the sphere, but it won't fall because it's sitting on top of that ground plane. It's actually a pretty simple premise, and we're going to walk through all of it from scratch right here. To start it out, we're actually going to create a new variable called ship position. Okay, this is a vector3 that we are going to reuse several times to position the ship and the sphere and the ground plane and the box all exactly where we want them relative to camera. Okay, this is a little bit of magic numbers that I figured out beforehand just to get into a nice good position kind of on the edge of the sea, but where the camera is kind of looking out, so it's positioned just right. Okay, now what we're going to do is we're going to create three things: the sphere, the ground plane, and the box. And we can do that very easily using the playground templates by hitting Control Space. That brings up a menu of awesome little snippets of code that we can reuse over and over and over again in all kinds of Babylon creations. So I'm just going to click here on Create a Sphere. I'm going to give it a diameter of 50. Then I'm going to create a ground plane, Control Space again, create a ground plane. I'm going to give it a width and height of 200, and then guess what? Control Space again, and we go and we create a box. Now I'm going to give that a size of 25. Okay, at this point what we want to do is we want to copy the position, the ship position, vector3, and we want to essentially position all three of those objects right there. So we're going to take sphere.position, .copy from, and that's going to be ship position. Okay, same exact thing with the ground plane, .position, .copy from, and it's going to be ship position. I know I'm going super fast here. Feel free to pause this video at any time if you feel like we're going too fast, and you can catch right on up. So same thing with the box, .position, .copy from, and then ship position. And now when we do that, we'll just hit play and see what we got here. There, you can't see the sphere, it's the box, excuse me, it's inside the sphere, but they're all right where we want them to be. Now I want the sphere sitting on top of the ground plane. So to do that, we're going to say sphere.position. Remember, it's got a diameter of 50 units. So we're going to say we want it to sit right on top, so we need it to rise half of that. And then we want box.position.y, and we're going to put that about 50 units below. Let's take a quick peek, see what we got. Now the sphere's on top, the box is down below. Okay, so now's a good time for us to actually add physics or physics properties to these primitives. And we can do that by using physics imposters. An imposter you can think of as a low resolution cage that sits around an object to be used in the physics calculations and the calculations for the physics engine. Using a low resolution cage is quite a bit more efficient than having a full high resolution mesh to do that. So we're going to use built-in physics primitives to do that, essentially, physics imposters. So let's start with the sphere. We're going to say sphere.physics imposter, and that's going to be a new Babylon physics imposter. Okay. And that is going to want the sphere to know what to apply it to, the sphere. And then we're going to say we want this to be a Babylon.physics_imposter, and we're going to use one of the built-in ones I mentioned, which is a sphere imposter for the sphere, okay? Now, we're going to give it a few parameters. I want to give this a mass of 1 and friction of 10. There we go. And then I'm going to just give that the scene. And then we're going to do the exact same thing for the ground plane. Ground.physics_imposter equals new Babylon.physics_imposter. And that's going to be the ground. It's going to be Babylon.physics_imposter.box_imposter. Even though it is a flat plane, we're going to use a box to calculate just so that there's a little tiny bit of a depth to it. And that's calculated automatically. But that way, it's better than saying using a sphere. And of course, we need something with some density to it. So box imposter is right there. And then with this one, we're just going to give it a mass of 0. And that's important because we don't want that ground plane to fall at all. We want it to be completely stationary. And it's going to hold up both the sphere and the counterweight, okay? And then we'll add that to the scene. And then finally, box.physics_imposter equals new Babylon.physics_imposter. That's going to take the box as an input. It's going to take the box imposter as well. We're going to use that. Same exact thing, .box imposter. And then it's going to have a mass of 100, okay? It's going to be pretty heavy counterweight. And then we're going to add that to the scene. Okay, so let's go ahead and play and see what we got. There goes our box falling with gravity. Bye-bye, box. Of course, the sphere isn't falling because well, technically is falling, but it's being stopped by the ground plane, right? The ground plane has no mass, so it's just sitting there. The sphere is trying to fall just like the box did, but the ground plane is stopping it. So now what we need to do is create a relationship or tie the box to the sphere with a joint, a special joint relationship that will essentially lock it into place and let it treat like that pendulum that we talked about. So we can do that by saying let joint1 equals new Babylon.physicsJoint, okay? And the physics joint is going to be Babylon.physicsJoint.lockJoint. And then it's going to have options to put in joint data. We don't have any, so we're just going to leave the options like that open. And then we're going to now effectively make that tie, use that joint and tie it to the box. And we do that by saying sphere.physicsimposter.addJoint. And the first thing that it's going to want to know is what is it being added to? Well, it's being added to the box.physicsimposter. And then we're going to use joint number 1, that joint relationship that we just created. So now when we hit play, that box is trying to fall, but it's being held up by a joint relationship to that sphere, which is also trying to fall, but it's being held up by the ground plane. All right, sweet. So now we've got the makings of exactly what we want. Now, to visualize this just a little bit better, let's really quickly add a material to our sphere just so that we can see what rotation looks like, okay? I'm going to say sphere.material is equal to new Babylon.standardMaterial, and I'm going to call it something simple like sphere mat, and we'll attach that to the scene. And then I'm going to say sphere.material diffuse texture is equal to new Babylon.texture, and we're going to give it a location for a texture. Now we have a built-in texture library. In fact, check the description down below. I'll give you some documentation on where you can find some of the built-in asset libraries with Babylon. But in this case, I'm just going to type in textures, Amiga.jpg, and we'll hit play, and we should see, cool, a nice little texture added to that. That'll help us visualize what's happening with that joint relationship. So right now, the box is just pulling the sphere straight down. Nothing fun is happening at all to it. So what we'd like to do is be able to apply some sort of a force or an impulse to that box to get it to kind of move a little bit. So let's visualize that here. Let's set up a scalar. How hard are we going to hit this box? So we'll call that magnitude. And that's going to be equal to 2000. And then what we're going to say is we're going to say box.physicsimposter.apply impulse. Okay. Now the apply impulse is going to want a vector basically where is it headed and where is it hit. Those are the two parameters that it's going to want. So first thing we're going to do is we're going to say new Babylon.vector3. And the vector3, we're just going to give it kind of a random, we're going to say negative 0.5 plus math.random. Okay, and this is just essentially and then that's going to be 0 for y, same thing for z. Basically what we're doing is we're just looking in some horizontal direction and picking a random value, and we're going to hit that box in a random with a random vector off in some random direction. Okay, so this one is going to be the same thing, negative 0.5 plus math.random. Okay, we want to scale that entire vector3. Let's see, dot scale. And when you scale that by the magnitude, that's how hard we were going to hit it. Remember, that's the thing that we, magnitude, there we go. How hard we basically wanted to hit. So we're going to pick a random direction, and then we're going to scale it or multiply all of the vector3 attributes by that same amount. And so we're going to give it a nice force off in a specific direction. And we can increase or decrease that force with just a single variable. And then we want to know where to hit the box. So in this case, we're going to say box dot physics I think it's a get absolute position. There we go. The box dot get absolute position. So now when I hit play, what you'll see is that the sphere is actually moving a little bit because we've hit that box. In fact, if we look straight down, you can actually see, cool, it is definitely moving. Now there's a problem though. Even though it's not too bad, what if we increased the magnitude by quite a bit? Let's say that we multiplied it by 5 here, and now we really see that that sphere is headed off the ground plane. In fact, if we're not careful, it might just fall. Uh-oh, is it gonna go? Is it gonna go? Maybe. I don't know, looks like it's just barely hanging on the edge there. Well, there's a problem. We don't want our ship just to randomly feel like it's moving around. We want it to be stationary. So what we need to do is we need to lock the position of the sphere every single frame. We need to hard code it. Say, before you render, override everything else. Your position is always going to be in the same exact place. And there's a really cool method to do that in Babylon. What you can do is you can create a new function for the on before render observable, which means before the scene renders, run this code. And we do that like this: scene.onBefore render observable .add, and we're going to add a new function in here like this. Okay, and we're going to say that we want to have the sphere dot position equal to new Babylon.vector3. And that vector3 is going to be very similar to the ship position, negative 160, but it's also going to include our desired y height or position, and then it's going to be 160. So now let's apply that same force, and we'll look up above, and you'll notice that it is not moving at all. It is stationary right there, because before the frame renders, and currently we're rendering on my setup here, you can see if I get rid of my picture. Actually, no, you can't. Sorry. We're rendering at 60 frames a second. There's output on the below the window where it says your frame rate in the Babylon playground, and we're rendering at 60 frames per second. But you may notice that it's actually moving and rotating like this in Y, and we don't want that. We want our ship to rock in X and Z, but not in Y, because that's not supernatural in the real world, at least not any ships that I've seen. So what we're going to do is we're going to say sphere.physicsImposter dot get angular velocity, okay? And we're going to set that to be a variable called velocity. So velocity equals sphere.physicsImposter.get angular velocity. So now we know the angular velocity basically before every frame is rendered. And then what we're going to do is overwrite the Y rotation, okay? We're just going to say 0. I don't want you to move at all in Y. So now we have the original X angular velocity, the original Z angular velocity, and we've overridden Y with 0. So now, of course, what we can do is we can say sphere.physicsImposter.set angular velocity, and that can be equal to velocity. And now when we hit play, you'll notice that it does what we want. It's not going to rotate in Y. It is going to rotate in X and Z a little bit, but this position right here is always going to stay basically facing forward, which is essentially what we want. Now we're bouncing around just a little bit too much, but the one thing that we need to know is that we are actually just hitting it one time when the scene first loads, so it will essentially eventually settle down. Now, currently we've hit it really hard, so it's going to wobble for a while. But we're hitting it really, really hard. So I think what we want to do is put that back to 2000, but we also want to apply a new force every so often, okay? And we can do that very, very simply by saying let interval equal set interval, okay? And we're going to do a function here, and that interval is going to run every, let's say, 4 seconds, okay? And what we're going to do is we're going to basically the exact same thing that we did to the box before. We're going to apply the exact same thing basically every 4 seconds. So every 4 seconds, we'll pick kind of a random direction scaled by our magnitude and kind of hit the box off in that direction. So if it's really going this way and we apply the opposite force, it should stop or slow down and go the other way. Or maybe it'll kind of start to go in an arc. You never know. It kind of apply a randomness to it, which will be rad. And so we can actually play that. Well, before we do, let's do one thing here. We also want to register on dispose observable dot add, and we want to, just for housekeeping purposes, really clean this up. So we want to make sure that we do a function and that we clear the interval that we had created before. Okay, so basically once it's done, we're just going to really do our own cleanup here, make sure everything is as performant as possible. So now I'm going to hit that, and let's take a look at this box. We hit it a little bit, and after about 4 seconds, you'll see that it'll get another nudge here. In fact, I think it already did. There, it just got one. It's a little bit hard to tell visually, but you can kind of see what's happening here with the box, but it is definitely getting nudged a little bit. Now we got a little bit of squirreliness, a little bit of movement here. It's possible we might want to decrease the magnitude just a little bit, but we are hitting that several times. And so for now, for our purposes, it's pretty good. In fact, I think if we just increase the mass of the box, it'll probably slow it down as well. There's different parameters that you can kind of play around with. There you go. That looks a little bit better. We basically made it quite a bit heavier, so the magnitude of the force we're hitting with is a little bit less. 6-to-1 on how you do that. But you can kind of see it's just getting this nice little subtle rocking motion. Okay, so we are in good shape now to bring in the black pearl finally, okay? So control space, again, to bring up our playground templates, and we'll import a mesh with callback, okay? In this case, I'm gonna get rid of the name. We're not looking for a specific name because it's a whole bunch of meshes. And I'm going to bring it in from the exact same place we did the stud, okay? And that's Babylon.js.github.io, and that's assets, meshes, and then we're looking for black pearl.glb. Now, when I hit play, we'll load the pearl, but it's off in the wrong location. So we need to use the ship's location again to say new meshes, because remember, that's in the callback function. Once the mesh has loaded, it gives us essentially everything that was loaded. So the first thing, which is a root node. So let's just go ahead and check that out. It's this root node of all of these different Lego parts for the ship. We want that root node. So that's new meshes 0. That is the root node. Okay. And we want to set its position to copy from the ship position, right? So now it'll be exactly where the sphere is. However, we actually want to now parent it to the sphere. So we'll do new meshes 0 to get that same exact thing. And then we're going to set parent to be the sphere. Okay, and now, just like that, we have the pearl parented to the sphere, which has a little bit of a rocking motion to it. Awesome, and then of course, you can probably imagine, last 2 things that we need to do is we're going to just turn off the visibility of the sphere. Ground as well. Ground.visibility equals 0, and box.visibility equals 0. And then finally, we're going to go uncomment out all of our stud ocean code here and hit play, and we should end up with an absolutely dynamite Lego scene. And here we go, full screen. There it is. We made it together. How cool is that? That we were able to use physics and apply some random impulses to a counterweight to give it that cool little rocking motion, right? On top of an entire sea of thin instanced Lego studs. This is just so much fun. You can, what we'll do here is we'll actually go ahead and save that out so you can have access to the final version as well. And then I'll also put in one little special extra bonus that you'll have to check out by clicking down in the final version in the description of the video down below. Thank you so much for joining me on this adventure. I hope that you've learned something, maybe just a peek into my childhood and what spawned the pirate obsession. I also hope you learned a little bit of something about how physics works in Babylon.js and how you can use physics joints to create some really cool relationships and seemingly random animation. Thanks again for joining me. If you haven't already had a chance to do so, please consider subscribing to this channel, and we will catch you on the next one.